for college algebra is applications and modeling with linear equations. So what we're going to be doing is solving story problems, basically, which is, as this says, one of the main reasons that we learn math. It's pretty powerful to use in solving all sorts of applied problems, and we'll just look at some of the some categories in geometry, motion, mixture, and then modeling. So they have this 6-step problem solving method, and they refer back to this throughout the textbook. Step 1 is to read the problem, figure out what information is given, what are you supposed to be finding. Step 2, assign a variable. And when you do that, you want to also define it. So you're going to write down what it represents. Make sure that that is in terms of quantities. So for example, I would not want to say x equals apples. I would want to say x equals the price of a bushel of apples, or the number of pounds of apples, or something like that. It needs to be a quantity. Step 3, write an equation. Sometimes there's more than one equation that can be written, and you'll need to work with the 2 equations together to get things solved. Step 4, solve. Step 5, state the answer. Make sure you're using correct units. Check to see if it seems reasonable. And then step 6, check the answer in the words of the original problem. And that's, again, for me, that's kind of like make sure it makes sense. You'll have to excuse the dog. She really hates squirrels, and there's one in the yard. Okay. Geometry problems. Finding the dimensions of a square. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. Okay, let's figure out what we got going on. We have the length of each, if the length of each side of the square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original. Find the dimensions of the original square. So what we're supposed to be finding is the dimensions of the original square, and since a square has equal sides, then I'm going to label my original square as x for the length of the original square side. And then we're increasing each side by 3 centimeters. Is increased by means add 3 to. So I'm adding 3 to the original length. So each side here will be x plus 3. And when we do that, the perimeter is 40 centimeters more than, which means add 42, twice the length of each side. Twice the length of means 2 times. So the perimeter of the new square, remember for perimeter of a square is 4 times the side length. On your next page you're going to have a formula sheet. So you've got perimeter is 4s when you have a square. And since the original side length is x, it's the perimeter of the new square. So the new square is x plus 3 for the sides. So the perimeter of the new square is 4 times x plus 3. And they're telling me that that is equal to 40 more than twice the length of each side of the original square. So twice the original square is 2x, and then add 40 to that. So this is telling me that this word is means that they're equal. Perimeter of the new square is equal to 2x plus 40. So we've got an equation. 4 times x plus 3 is equal to 2x plus 40. Now usually once we have these written, they're pretty easy to solve. So we'll solve this one by distributing the 4 and then moving all of our variables to the same side. So 4x plus 12 equals 2x plus 40. I'm going to go ahead and move the x's to the left, because you know I like variables to start off with positive coefficient. Subtract that 12 over. So I have 2x equals 28. And divide both sides by 2, and I get x equals 14. So that is going to be the original square's measurements. So when it asks for the dimensions of the square, depending on how the MyMathLab is set up, it might just ask for one measurement, but it might also ask for the length and the width. But the original square is 14, what are we measuring in centimeters? By 14 centimeters, or has a side length of 14 centimeters. Example 1.5. The length of a rectangle is 2 inches more than the width. If the length and the width are each increased by 3 inches, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. Find the dimensions of the original rectangle. Okay, so here is my rectangle. I have a length and a width. To start with, it tells me the length of a rectangle is, which means equals, 2 inches more than, which means add to, the width. 2 inches more than the width. So the length of the rectangle would be w plus 2. So instead of labeling this as length, I'm going to label it as w plus 2. Now, if the length and the width are each increased by 3 inches, length and width are each increased by 3. So now I have a bigger rectangle where I've increased the width by 3 and the length by 3. So w plus 2 plus 3 would be w plus 5. So once I've done that, the perimeter of the new rectangle will be, that's another equals, 4 inches less than, which means subtract 4 from, 8 times the width of the original rectangle, which is w. So the equation I'm going to be writing has the perimeter of the new rectangle, which means I have 2 of the long sides plus 2 of the short sides, and that is going to be equal to 8 times the width of the original rectangle minus 4 inches. Once you have these set up, they are pretty easy to solve. So I might, I don't know, I was going to say I would save time and not solve them, but it doesn't take that long, so I'll just go ahead and work through this. Distribute your 2's. So we have 2w plus 10 plus 2w plus 6 equals 8w minus 4. Combine your like terms. So I got 4w plus 16 equals 8w minus 4. I'm going to move my w's to this side and my constants to the other. So now I have 4w equals 20. Divide both sides by 4, I get w equals 5. So they want the dimensions of the original rectangle. Now we know that w is 5. So I can come back to the original rectangle and say that the original rectangle is 5, my units are inches, 5 inches wide, and the length is w plus 2, so 7 inches long. Don't forget you have these formulas on the next page in case we forgot how to find the perimeter of a rectangle. They are right there. We'll keep that handy because I think we might need it later. Motion problems. In a motion problem, the 3 components, distance, rate, and time, are denoted by the letters d, r, and t respectively. The rate is also called the speed or the velocity. Here, in these problems that we're going to be doing in this section, the rate is assumed to be constant. So then we have three potential equations that we can use with these motion problems. The first one is distance is equal to rate times time. I call that the dirt formula because it just looks like it says dirt. And then if I were to divide both sides by r, then t would be by itself, and I would have t equals d divided by r. If I go back and divide both sides by t instead, then r would be by itself, and I would have r is equal to d divided by t. So here are the three equations that we're going to be using when we have constant motion problems. I mean, there's more to it, but we will get into that as we go. Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo because he lives 40 miles further away. Eduardo travels 5 miles per hour faster than Maria. Find the average rates. So I am going to actually set this up in a table. I'm going to have rate, time, and distance. And then we'll fill in information. So we'll have one for Maria, one for Eduardo, and then they are each going to have a section for their rate, time, and distance. Usually when we're solving these, what we will do is fill in two of the columns and then use one of these equations to fill in the third column. So let's see what information we are given. The trip takes 2 hours for Maria. So Maria's time is 2 hours, but it takes 2.5 hours for Eduardo because he lives 40 miles further away. So 2.5. Eduardo travels 5 miles per hour faster than Maria. So when it says 5 miles per hour faster than, that means we're going to take Maria's rate and add 5 to it. So Eduardo's is going to be Maria's added 5 to it. So we should let Maria's rate be our variable. So I'm going to say x equals Maria's speed. And I'll put that in the rate spot for Maria. And then Eduardo's is going to be Maria's added 5. Perfect. This 40 miles farther away, that is actually just distracting information. We're going to leave it for now, and we're going to fill in these distance columns here. And we're going to fill those in using the formulas. So since I'm needing the one for distance, I'm going to fill it in by doing rate times time. So in this column, I'm going to take the rate times the time from the other boxes. So Maria's is going to be x times 2, which I'm going to simplify to make 2x. And Eduardo's is going to be 2.5 times x plus 5. Now that our table is all filled in, we have to see what else the problem is telling us. The problem says that Eduardo lives 40 miles farther away. So this is telling us how our distances are related to each other. So that's going to tell me that Maria's distance and Eduardo's distance are not equal to each other. So if I wrote down the equation that Maria's distance is equal to Eduardo's distance, that would not be a true equation because Eduardo lives 40 miles farther away. So Eduardo's distance is going to be Maria's distance, but 40 miles further away. So I have to take Maria's distance and add 40 to make those two things equal. Eduardo's already going further, so I have to do 40 plus Maria's distance so that the two are equal. Now I have a true equation, and I can go ahead and solve it. So I will distribute this 2.5, and now I have 40 plus 2x equals 2.5x plus 12.5. And then just solve this equation. So I'll subtract 2x from both sides, subtract 12.5 from both sides, and then I get 0.5x equals 27.5. And then divide both sides by 0.5, which is going to give me x equals 40, 55. But I have to know what that 55 represents so that I can use it to answer my question. The x represents, up here, Maria's speed. So now I know that Maria's speed is 55, and we're measuring in miles and hours. So Maria's speed is 55 miles per hour. And then Eduardo's speed, if I look in my table here, says x plus 5. So Eduardo's speed would be 55 plus 5, or 60. So then Eduardo speed is 60 miles per hour. So make sure that you know what your variables represent and you know what question you're being asked to answer. Example 2.5. Kevin drove home from college for a weekend visit. He averaged 40 miles per hour driving there on Friday. As he returned home on Sunday, traffic was lighter, so he was able to average 48 miles per hour, and his driving time was 1 hour less. What is the distance between Kevin's home and his college campus? So this time we are going to have our table, and one of them is going to be on his way to home from college. So on his way to home, and then on his way back to college. He has 2 trips. So we're going to have our rate, time, and distance. So on his way home, he averaged 40 miles per hour. As he returned home, traffic was lighter, so I should have said returned to college. That's a little confusing. As he returned to college on Sunday, traffic was lighter, so he drove 48 miles per hour. And his driving time was 1 hour less. So 1 hour less means subtract 1 from. Doesn't sound like we know how long it took him on Friday. So I'm going to let x be the amount of time it took to drive home. Not to college. Amount of time it took to drive home. So I'm going to put x there, and then it took an hour less, so I'm going to make this x minus 1. So I have my 2 columns filled in from the information I was given, and then I'm going to fill in my 3rd column using the formula. Again, since I'm filling in the distance column, I'm going to take the rate column times the time column. So in this space, I'm going to have 40 times x, and in this space, I'm going to have 48 times x minus 1. It's important that you get parentheses around your x minus 1, because it's one entire, that's the amount of time, and we need to remember to distribute. So in this case, when Kevin is driving from college to home and driving from home to college, the distance that he's traveling each way is the same. So in this case, these two distances are equal because it's the same trip, just in the reverse order. So when we write our equation, we'll make it 40 times x equals 48 times x minus 1. And then we'll solve this by distributing that 48. So we have 40x equals 48x minus 48. Oh, I'm going to have a negative variable. It'll be all right. Subtract your 48x over because it's more efficient. We get negative 8x equals negative 48. Divide both sides by negative 8, and we get x equals 6. Now, if we quit there and put 6 in for our answer, we are going to get that wrong because x is the amount of time it took for Kevin to drive home. So 6 is a number of hours, and we are asked to find what is the distance between Kevin's home and his college campus. So if we look at our distance column, I see that I have two options for how to figure out that distance. Since those distances are the same, I could use either one. It looks to me like 40 times x is going to be more faster to do. So I am going to use that my distance is equal to 40 times x. So 40 times 6, which would be 240. So then the answer I'm looking for is that it is 240 miles from home to college, or from college to home. The distance between the two places is 240 miles. What's next? Oh, we have another distance, rate, and time problem. This one left a lot of space. Bob took 10 minutes to paddle his boat upstream to fish at his favorite spot. Coming back later in the day at the same paddling speed, it took him 5 minutes. If the current in that part of the river is 7 kilometers per hour, what was his boat speed in still water? You see problems that are like this a lot, except sometimes it's an airplane going with the wind and against the wind. Sometimes, it might be a moving sidewalk. It might be you're on a river like this. Anytime you have two things that are moving, either against each other or with each other, then we're going to use this same setup. So you got to think about what is the kind of surrounding motion and what is the object that's moving. So when I have this situation, we have the river. Maybe I should use blue since it's a river. We have a river and we have a boat that he's paddling. The river is going to be going at a lower rate than the boat. Otherwise, Bob wouldn't be able to make any headway. So I'm going to have two situations. One where the boat and the river are going the same direction, and one where the boat and the river are going opposite directions. So when he's going upstream, that's the situation where the two are opposing forces. So this is our upstream scenario, and then this is our downstream. What's going on when we're going downstream versus upstream is that when we're going downstream, the rate of the current and the rate of the boat are being added together to get the overall rate. When we're going upstream, the rate of the boat subtracted by the rate of the current gives us our overall rate. What's really important though is that you keep them in the correct order. Whichever one has the faster speed has to go first in your scenario. So when we're going downstream, we're going to have the either boat or airplane, and we're going to add the current speed, which would be like the air speed around it. But when we're going upstream, the overall rate is going to be the boat speed minus the current speed. And that's what's going to go in the rate box when you're organizing your problem to get it set up. So let's make our table. We're going to have upstream and downstream. We'll have a rate, a time, and a distance. Bob took 10 minutes to paddle his boat upstream to fish at his favorite spot. So when he's going upstream, his time is 10 minutes. Coming back later in the day at the same paddling speed took him 5 minutes. So when he's going downstream, it took him 5 minutes. If the current in that part of the river is 7 kilometers per hour, what was his boat speed in still water? So our variable is going to represent the boat speed. It'll always say in still water or in still air or whatever. That just means if there wasn't a current, how fast would the boat be going? So we do have to take into consideration the current. So when we're going upstream, that's this, the boat speed, which was x, minus the current speed is what goes in this rate box. So the boat speed we don't know, that is x, minus the current speed, which they told us is 7. When we're going downstream, the boat and the current are working together. So the boat speed, which was x, gets added to the current speed of 7. Now, one thing you may have noticed is that the units here are kilometers per hour, and the units for our time is in minutes. So I'm going to have to change my 10 minutes into hours. So here's what I know about my conversion factor. I know that 1 hour equals 60 minutes. So when I put that fence and rail in, I need my minutes to cancel, so that's going to go in the denominator. Hours will stay, so I'm going to put 60 minutes, 1 hour. The minutes cancel out, multiply across, I get 10 over 60 hours, which would simplify to 1/6, but I'm just going to leave it as 10 over 60. And then same thing for my 5 minutes. Times 1 hour over 60 minutes would be 5 over 60 hours. Sometimes this makes a difference, and sometimes it's okay if you don't do that, like you'll accidentally get it right, but it's always best practice to make sure that your units are consistent. So if our rate is in kilometers per hour, our time needs to be in hours, and our distance would be in kilometers. So we have our rate and our time columns filled in, which means we are filling in distance with rate times time again. So my rate is x minus 7, my time is 10 over 60, and downstream my rate is x plus 7, and my time is 5 over 60. Here's the thing about going upstream and downstream. If he starts and he goes upstream to fish and he comes back downstream, he's going the same distance. So these are going to be equal again. That doesn't always happen. Sometimes it'll say, we go a certain amount of distance there and back, and all together it's a certain amount. Then we would add them together and equal that certain amount. You just have to read every problem because they're all set up differently, and I could do 20 examples and there would still be one that's different. So we're going to set these two equal to each other. 10 over 60 times x minus 7 equals 5 over 60 times x plus 7. I don't know if we've talked about clearing fractions yet, but we can clear these fractions by multiplying both sides by that denominator before we distribute. So I'm actually just going to multiply both sides of this equation by 60 over 1. And what that's going to do for me is cancel out those over 60s. So like I said, sometimes you don't really have to convert your units, but sometimes you do. So in this case, we got lucky if we didn't, but we went ahead and did it, so now we know. And then to solve this equation, I am probably just going to distribute the 10 on this side and the 5 on that side. So I have 10x minus 70 equals 5x plus 35. And solve. So we get 5x equals 105. Divide both sides by 5. And that would be x equals 21. So 21 is x. X was my boat speed. And the question is asking, what was his boat speed in still water? So now I have my answer. I can say the boat speed was 21, and my units were kilometers per hour. Mixture problems. Problems involving mixtures of two types of the same substance, like salt solution, candy, and so on, often involve percentages. They don't always involve percentages, but honestly, the setup is always going to be the same, whether it's percentages or like cost per pound. When you set up your table, instead of using distance, rate, and time, you're going to use the rate or percent of concentration as a decimal times the quantity or amount of that item you have, and that's going to equal the amount of pure substance present. So we're going to take our percent as a decimal times the quantity that we have, or number of liters, and that's going to be the amount of that substance, whether it's acid, money, whatever it is. The concentration, this is just a hint, the concentration of the final mixture has to be between the concentrations of the two solutions. If you have a problem that's like mixing two kinds of candies or like chocolates or whatever it is that are different price amounts, instead of using the percent as a decimal times the quantity equals the amount of substance, it would be the cost per pound times the number of pounds equals the amount of money for that item. So maybe we should write that down. For blends, like blends of coffee, blends of candy, blends of mixed nuts, whatever it may be. It's going to be the cost per pound times the number of pounds equals the amount of money. So that's just a different setup. So let's look at one of these with chemicals. A chemist needs a 20% solution of alcohol. She has a 15% solution on hand, as well as a 30% solution. How many liters of the 15% solution should she add to 3 liters of the 30% solution to obtain the 20% solution. Okay. Let's see. I think I might want to draw like a picture first and then maybe put that into a diagram. So if we have a 20% solution and we are adding it, oh no, she needs a 20% solution. That's our equal to side. She's going to be adding a 15% solution and a 30% solution. We don't know how many liters of 15%, but we do know it's 3 liters of 30%. So this is 3 liters. This is X liters. So we're going to say X equals number of liters of 15% solution. That's what we're going to be solving for. So if I mix X liters of 15% and 3 liters of 30%, then over here I'm going to have X plus 3 liters of 20%. So how does this look when I write an equation or make a table? So if I have a column for the strength of our solution, we have a 15%, a 30%, and a 20%. Then we have number of liters. We have X of the 15%, 3 of the 30%, and X plus 3 of the 20%. And then in this column, it's going to be the amount of alcohol, the total amount of alcohol contained in that. And we get that by multiplying the strength times the number of liters. So I'm going to fill in this amount of alcohol column by multiplying the strength times the number of liters. Remember that the strength has to be in decimal form. So this will be 0.15, this will be 0.3, this will be 0.2. So in this column I have 0.15 times X. In this column I have 0.3 times 3, which is actually 0.9. And in this column I have 0.2 times X plus 3. Okay, how do I make an equation out of this? Well, I'm just going to use this right-hand column right here, over here in the end. What I'm doing is mixing the 15 and the 30 and ending up with the 20. So these two get added together and they are going to equal this column, this little box. So the 0.15x plus 0.9 is going to equal 0.2 times x plus 3. 0.15x plus 0.9 equals 0.2 times x plus 3. And then go ahead and solve that little equation. Distribute your 0.2. So 0.15x plus 0.9 equals 0.2x plus 0.6. Subtract. Again, I'm going to try and get positive coefficients. So I have 0.3 equals 0.05x. Divide both sides by 0.05. And I get x equals 6. And that x represents the number of liters of 15% solution, which is the question that's asked, how many liters of 15% solution. So I'm going to say we need to use 6 liters of 15% solution. An artist has sold a painting for $410,000. He invests a portion of the money for 6 months at 2.65% and the rest for a year at 2.91%. His broker tells him the two investments will earn a total of $8,761 in simple interest. How much should be invested at each rate to obtain that amount of interest? Here we have this simple interest. I feel like we've seen that in a previous section. Simple interest formula is interest is equal to principal times rate times time. So we're going to be using that in a little organizational table to figure out how much he should invest at each of those rates, or each of those, the 2.91% and the 2.65%. All right, let's go. So we're going to have the principal. That's the amount invested. We are going to have a rate. We are going to have time. And we are going to have interest. We'll fill in what we know, and then use the formula to fill in what we don't know. An artist has sold a painting for $410,000. He invests part of the money at 2.65%. So I'm going to put 2.65, but then I remember that has to move over 2, so it's 0.0265. And then the rest of it at 2.91%, which would be 0.0291. We'll get back to this column. He invests for 6 months at 2.65%. So remember that time is going to be in years. So if we are investing for 6 months, that is half a year. So I'm going to put 0.5 there. And the rest for a year at 2.91%. So that time is going to be 1. We're going to have to go back here to the principal. So he has a total of $410,000 to invest in these two accounts. So this total is $410,000. So what I'm going to do is I'm going to choose one of those to be my variable, and then I'm going to use that total to get the other box filled in. So if I let this be X, I just don't know how much I'm investing in there. I'm just going to assign that to the variable X. Then I know that this other box, let's say I put it at Y. I'm going to have to change that though because I don't want to have two variables. I know that X plus Y is $410,000 because that's how much total. But I don't want to have two variables. So I am going to move this X to the other side, and the other amount of principal is going to be $410,000 minus X. Because if I put X dollars here, that's going to be how much I have left. So I'm not going to use Y. I'm going to use 410, try it again, 410,000 minus X. And that's going to be the principal in that other account. Alright, then I'm going to fill in this column with the formula principal times rate times time. So I'm going to have X times 0.0265 times 0.5. And then in this box, I'm going to have the principal, 410,000 minus X, times the rate, 0.0291, times the time, 1 year. And then here's what I know about my interest. His broker tells him the two investments will earn a total of $8,761 in simple interest. So my total interest is $8,761. And the way that I get my total is by taking this interest plus this interest to equal my total. And that total was 8,761. So the equation that I'm going to be solving is x times 0.0265 times 0.5 plus 410,000 minus x times 0.0291 times 1 equals $8,761. That may look like a little overwhelming for an equation, but we're just going to take it a step at a time. I'm going to do 0.0265 times 0.5 times x, which is going to give me 0.01325x plus. In this little chunk, the times 1 isn't going to do anything, so basically I'm just distributing 0.0291 to each of those terms. So the 0.0291 times 410,000 is 11,931, and then minus 0.0291x, and then this side just stays 8,761. Alright, let's combine our like terms. So doing 0.01325x minus 0.0291x actually leaves me with a negative number, negative 0.01585x equals, and then I'm going to subtract 11,931 from both sides, which also gives me a negative value of negative 3,170. Then we just need to divide both sides by negative 0.01585. And we get x equals 200,000. Well, that worked out nicely. The question is asking us, how much should we invest at each rate? So now I know that we are investing 200,000 at which interest rate was the x? X was at 2.65%. And then the rest of it, 410,000 minus x. So 410,000 minus 200,000, so 210,000 at the other interest rate of 2.91%. Modeling with linear equations. A mathematical model is an equation or inequality that describes the relationship between two quantities. A linear model is a linear equation. Remember, that means that the degree is 1. So in these problems, they're going to give you a scenario and they give you an equation, and then they just ask you to answer some questions. So we just really need to understand what the problem is about. We don't need to have a whole lot of background knowledge, and then just kind of take it from there. If a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters of air per second, then the percent P of contaminants that are also removed from the surrounding air can be modeled by the linear equation P equals 1.06 F plus 7.18, where F is between 10 and 75. What flow F to the nearest hundredth must a range hood have to remove 50% of the contaminants from the air? So in this model, they should have told you, they didn't do a good job of letting you know that you're not going to change this 50% into a decimal. This is literally going to be P. P is 50. So I'm going to put 50 in for P equals 1.06 F plus 7.18. That's really all we have to do is replace the letter P with the number 50, solve this equation, So we get 42.82 equals 1.06f. Divide both sides by 1.06. And we get f is, I have my calculator going. Let's see, 42.82 divided by 1.06. 40.39622, lots of stuff. 40.39622 641509438, and it keeps going. But we're supposed to round to the nearest hundredth. So I'm looking at 40.3962. There's more to it, but to the nearest hundredth, here's tenths, here's hundredths. So I'm rounding here, which means I look here. That is more than 5. 5 or more, we bump up. So I have to bump this up to a 0, which then in turn bumps this up to a 4. So I would have to answer that it is 40.40, and the units for F was liters of air per second. When it says round to the nearest hundredth, your answer has to have something in the hundredths place. So I could not just answer this 40.4. I have to have that 0. Next model, the projected per capita healthcare expenditures in the United States, where Y is in dollars, X is in years after 2010, are given by the following linear equation. What were the per capita healthcare expenditures in the year 2018? So if X is years after 2018, or excuse me, after 2010, I'm wanting the year 2018, so I'm going to do 2018 minus 2010, and that is giving me X equals 8. So they're asking what were the healthcare expenditures? That's the letter Y. So for part A, I'm going to substitute 8 in for X. So Y equals 416 times 8 plus 8,042, which is 3,200 plus 80 plus 48. What is that? I don't know. I have a calculator. 416 times 8, 3382. Plus 8,042. So 11,370. And that is in dollars, so that would be $11,370. If this model continues to describe healthcare expenditures, when will the per capita expenditures reach 13,000? So now this is telling me the expenditures are 13,000, so that is our Y value. And they want to know when, which is find X. So I have 13,000 equals 416X plus 8,042. And we will just solve that equation. So subtract 8,042. 416x equals, I should just keep this open. Come on, buddy. 13,000 minus 8,042. 4,958. Divide both sides by 416. I don't think I did that right. Try again. 4,958 divided by 416. There we go. 11.91 something. So the question does not ask after how many years. it asks in what year. And since X represents the number of years after 2010, so 2010 plus 11.918 whatever years would be 2021.918 whatever. But until that rolls over to the next year, this is actually the year 2021. So this happens in 2021.